resuming our discussion, and next we're going to inspect the rules that we have mined. So we have discussed rule quality measures in class, and we have noticed that default measures that the a rules package use is support and confidence. And now I'm going to add to the rule max that we have mined, I want to add additional qualities. So I'm going to use column bind to the current quality measures of this rule set. I'm going to add this cool and imbalance measures, imbalance ratio as we discussed in class. Okay, so once I run this, we will see the summary. In the summary, we will see that we have more metrics being reported. Support, confidence, coverage, lift, count, cool, and imbalance. So what is coverage? We did not talk about in class. Coverage is actually the support of the left hand rule. So it basically talk about how to what extent this rule might apply. So how many transactions actually match the left hand side of a rule. So here we have for each measures, we have the min and the max in this rule set. So we can see support being generally low. This is typical in mining in large data set because for a rule with multiple elements, multiple items in the left-hand side, and some elements on the right-hand side, co-occurrence of all those often represent a small portion of the total transactions. Confidence range, we have a confidence set. We will mine the rules. Where was our confidence? 0.3. So it starts with 0.3 and up to 99%. Coverage is related to support. As you can see, it's pretty low. Lift, we have negative, less than 1 and greater than 1, but it's not strong in any case. Count is the absolute support. And cool, also the values are fairly low. So we don't actually have very strong items that strongly associate with each other because the maximum cool is only 0.5, which is basically neutral. And we can see the rule sets cover some rule which is quite balanced and rather imbalanced. Okay. So we have an overall idea of our rules mined, and now we can actually examine those rules. Another way that you can actually look at this as a different representation, you can run this T method, which creates a table for the top 5 rules. It's going to list all the measures that we have requested. So if we run this, we have for the top 5 rules, we have we select the first 5 rules. So here are the 5, and for every of them, all the measures that the system can compute are computed. Okay. So now let's start to inspect the rules. I can, ask for the system to display the first 10 rules ordered by lift. And I can also, so those are the first 10 rules. Let's look at 1 or 2 of them. So it says that if manner of death is short, gender is M, and state is California, and then it's associated with the race H. But we can examine the goodness measures. We see that we can see that support is 0.5, 0.05, confidence is quite low, coverage is quite low, lift, although it shows positive, but cool basically says it's negative. So, and even though it's pretty imbalanced, this is not really a strong rule, right? And we can look at the other, and this shows some of the issues with the rules that's being generated. So from the same frequent item set, we can generate multiple rules. As you can tell, this rule is generated from the same frequent item set as the first one, the first rule. So this rule says short gender is male and race is H, then state is CA. You can see all those 4 elements are exactly the same between rule 1 and rule 2. Again, checking our goodness measures, so we see this again is not a very strong rule. So we can also do the same thing, but order the rules using different measures, and you can look at the details. And additionally, you can use multiple criteria to order the rules and to inspect those rules. Some other ways that we can check the rules, for example, we can see, we can find the rules with the right hand side contains race equals B. Let's try that. Use the size of the screen. So we can see this inspect statement did not give us anything, which means that we didn't have any rules generated from maximum frequent item set that has race B in the right hand. Let's try either B or H. We can select those rules with B or H on the right hand side. And we found one rule. This rule is manner short. I think we have examined this rule before, and we said it wasn't a very strong rule. We can actually say anything that contains race, no matter which value of the race was involved in the right hand side. We do that. Then we have a few more rules. We can see it's most of the rules predict a race to be white, because as we know that most of the cases involves victims which has race white. So again, if we look at the support, fairly low. If we look at all the Q values, fairly low. Those indicates that negative association. Which says that this data set does not present, so we don't have a strong pattern involving race in this data set. So the maximum rule set, because as our definition tells us, max rule set contains the longest rules. That may not actually give us all the examine only the maximum data set may not actually review all the information there is. So you can also check the qualities by using rule length. So I'm leaving the maximum set. I'm going back to the original rules that we have mined using the support of 0.5 and confidence of 0.3, right? So this is our original rules. So to this rule set, I attached those new quality measures. So let me attach that. And then I can inspect those rules. I want to look at the rules by Cook, by Koo, the value, and give me the top 10 rules matching this condition. So I want the left hand of item is between 2 and 4. Okay, so let me inspect that. It's going to give us a few more rules that have stronger Koo values. So here we can see the strongest Koo value is 0.79, which is fairly strong, indicates positive association. So what we see here is this rule says gender is male and armed type is gun, then the manner of death is in shot. And we can see the support is fairly strong and confidence extremely strong. And it's still considered roughly balanced. Lift, although say there is not strong correlation, but Koo says the value, this rule is a fairly strong rule. And so, which basically tell us that it's likely when the gender is male and armor type is gun, then it's likely that this the manner of death is going to be being shot. This reminds me, well, yeah, we already examined the gender imbalance in this data set. A majority of the cases involve male. Well, I think it's intuitively understandable, but still it's concerning that maybe male has actually invited more violence from the police. Yeah, well, at least I have this question in my mind. I don't have lots of evidence to support my any of the arguments that might be made, but that's observation that I just come to my mind that I don't know how many well, I don't know average encounter with police, whether male is actually dominate all the encounters. If among all the encounters, if male and female are equally distributed, then why male being the major target for police shooting victims? Well, anyway, those are the questions in my mind. Okay, so we have looked at some of the rules and look at ways to inspect these rules. And next, we can actually look at the a rule viz package. This allows us to visualize the rules. We have mentioned the visualization a while ago. But now we can actually look in more detail. So we selected this subset rule involving race, and we know that those race rules are not strong, okay? This visualization demonstration is only going to show how to use those visualizations. So we can actually now plot using, there are multiple type of engines that we could use. So we're going to create a scatter plot using the Koo value as the shading, and use support as the measure, and the engine we choose is interactive. This can be very slow. If you have a slightly larger rule set, this is going to be very, very slow. But let me see. Okay. So now we're entering the interactive mode. now we need to use the controls provided in this graph to actually interact with. So we have a scatter plot for 21 rules, and we want to look at some rules with Q values that's a little bit stronger. This is roughly neutral, actually. It's stronger than 0.28. And I think we can do this by draw a box. Here and inspect. I think we covered the 2 rules. So here in the inspect area, we can see what rules are those 2 rules. And we can select a different set by clicking in one spot and then click on another spot. Then a rectangular area is created. If we click on inspect, we're going to see those rules being displayed here. We have 4 rules. We can also do filter. If you click on filter, the system is going to tell you select minimum Q value in the color key. So let's see if we want to select rules that has a Q value which is 0.3 and above. I'll just click here, and then all those rules will be selected. We can also, so this graph is now reduced from 0.3 to 0.4 and a little bit above. So as you can see, the rules has been filtered. We can zoom in and out, select a region first, and then zoom in. If we have many rules here, zoom in and zoom out going to make sense. So this is the interactive mode of visualize the rules using scatter plot. We can also use a graph. So here I have the engine I used is HTML widget and maximum of 20 rules. Oh, I said it's very slow. Let's see how slow this can be. Oh, actually we need to close this. Yeah, end this. Okay, and then we can actually start with the HTML plot to run that. So too many rules, only select the best 20 rules. So here we have this graph display of the rules. There's filters. We can actually find rules that involve gender is male. So here are the rules. And we can click on those, mouse over those rules to see what those rules are. Gender is male and race is white, and here are our scores. If we click on this, and then we can actually examine this particular rule, which is rule 12. We can see the direction of those rules express the rule itself. So we have 3 conditions on the left side. So we see 3 conditions coming in and 1 consequence coming out. So the arrow of the direction tells you that. This is one of the attributes, the item age group DT. So this is one of the items involved in this rule. Okay. The color indicates what do we call it? We used what? the color should be the goodness measure. In this case, because my screen is kind of I think the default measure used is lift. So this color maybe indicates the lift score. So let's see. This lift is 1.44. This lift is 1.03. Okay. And the size of circle indicates the support. So this rule has a support 0.08. The smaller one should have a less support. Okay, so this is the two visualization tools that we could use to help us to filter and find good rules. So this concludes my demonstration on the association rule mining using police shooting data.